Good evening to all. Am I audible? Am I audible? Can anyone inform? Am I audible? Okay, I'm starting the class. So, I'm repeating this topic because last class it was not, the screen was frozen. That's why I'm repeating this. So, an open loop transfer function of unity feedback system is given. So, g of s is equal to k into s plus 1.5 by s into s plus 1 into s plus 5. So, this is it. So, this is the given numerical problem. Open loop transfer function is given. This is our open loop transfer function. This is the open loop transfer function. So, we have to sketch the root locus for the given system. So, step 1, to locate the poles and zeros. Step 1 is to locate the poles and zeros. So, the poles of the open loop transfer function are, they can be obtained from the denominator, that is s into s plus 1 into s plus 5. They can be obtained from the denominator. So, you just take the denominator, equate it to 0. So, if you take the denominator and equate it to 0, you can determine the poles s equal to 0, s equal to minus 1, s equal to minus 5. That is P1 equal to 0, P2 equal to minus 1, P2 equal to minus 5. So, zeros in the numerator you can see s plus 1.5. Therefore, there is only one 0, that is s1 equal to minus 1.5. Since there are 3 poles, there should be 3 zeros. But here only 1 0 is available, so we will assume that other 2 poles will meet, or the root locus which is going to start from the other 2 poles, we don't know exactly from which pole the root locus will start among these 3 poles. From which pole root locus will start and meet this 0, we don't know that. We have to plot it on the s-plane to know that. So, we have to plot it on the s-plane to know that. So, one of the poles among these 3 will meet this 0, minus 1.5, and other 2 poles through root locus will meet the 0 starting from any of these 2 poles at infinity. Okay. Okay then. So, here let us look at the zeros and poles now. Poles are represented, you can mark them x on the s-plane to show the poles, and you can mark 0 on the s-plane to represent the zeros. So, this is our s-plane. I have considered 2 centimeter equal to 1 unit. 2 centimeter is equal to 1 unit I have considered. So, one of my pole was at the origin. P1 equal to 0, other pole was at minus 1, P2 equal to minus 1, other pole was at minus 5. So P3 equal to minus 5. Now I have only one 0, that is Z1 is minus 1.5. So this is my pole, pole 1, pole 2, pole 3 and 1 0 at minus 1.5. This is 1 0. Okay, so since we are able to locate the poles and zeros, I'll give you a minute. If you are noting it down in the graph, just note it down. Now, so let us go to step number 2 to find the root locus on real axis. So let us find the root locus on the real axis. So on the real axis, we can see here on the real axis there are total 1, 2, 3, 4. Actually there are 4 poles to, there are 4 roots. All 4 roots are located only on the real axis. Here no root locus is there on imaginary axis, or there is no complex conjugate roots. So since there are no complex conjugate roots and there are no roots on the imaginary axis, so total we have 4 roots here. So let us consider the test point to locate the root locus on the real axis. So consider a point on the left side of your P1, that is known as test point. This is your test point. This is your test point, and look towards right. When you look towards right from this point, what we can see is the sum of poles and zeros, means the number of roots on the right side are odd. There is only one pole on the right side, so which that number is odd number. Therefore okay, the number is odd number. Therefore there will be a root locus. There will be a root locus lying from, it will start from P1 and it will end until it meets the another root on the real axis. Another root on the real axis. Now there is a root locus between P1 and P2. Now consider a test point on the left side of P2. Now look towards right. Now look towards right. From this point, look towards right. So when you look towards right, sum of poles and zeros on the right side of this test point are even. There are 2 poles here, which is an even number. Therefore there will not be any root locus between P2 and Z1. There will not be any root locus between P2 and Z1. Okay. So there will not be any root locus between P2 and Z1. Now consider a test point on the left side of Z1. Consider a test point on the left side of Z1 and look towards right. When you look towards right, sum of poles and zeros, if you see 1, 2 and 3. Total 3 roots are there. Okay. Since there are total 3 roots, therefore which is an odd number. Therefore, there will be a root locus from this 0 to until it meets another 0 or pole. Okay, there will be a root locus between Z1 and P3. There will be a root locus because on the right side of the test point we can see the odd number. Therefore, there will be a root locus. Okay, so draw a root locus from this Z1. There will be a root locus from Z1 to P3. Now consider a test point on the left side of P3. Consider a test point on the left side of P3 and look towards right. And look towards right. So when you look towards right, okay, the sum of poles and zeros, you can see 1, 2, 3 and 4. Total 1, 2, 3 and 4, which is an even number. So total 4 roots are there, which is an even. Therefore, there will not be any root locus after P3. So there will not be any root locus after P3. So root locus will be there from P1 to P2 and Z1 to P3. That's it. So I have drawn it in the next slide. Root locus will be there from P1 to P2 and from Z1 to P3. This is it. Just draw it. Take a minute and draw it. If any disturbance occurs, you just inform me in the chat box if you have any disturbance. So I am changing this slide. Now let us go to step number 3. Step number 3. In step number 3, we have to find the angles of asymptotes and centroid. To find the angles of asymptotes and centroid, okay, the formula is 180 into 2q plus 1 by n minus m, where n is number of poles. So n value here, number of poles are 3 here, n equal to 3. Number of zeros is only 1, therefore m equal to 1. M is equal to 1. Okay, so here n minus m is there, so n minus m, 3 minus 1 you will get 2. And what about q values? Q will vary from 0, 1, 2, 3 up to n minus m. What is n minus m? It is 3 minus 1, that is 2. So q will vary from 0, 1 and 2. Q will vary from 0, 1 and 2. Therefore, for different q values, that is for q equal to 0, angle, determine the angle, plus or minus 180 by 2 you will get, that is plus or minus 90 degree. So when q equal to 1, substitute in the above formula, you will get 180 into 3 by 2, that is you will get 270 degrees. For q equal to 2, you will get angle as 180 into plus or minus 180 into 5 by 2, you will get 450 degrees. So if the angle is greater than 180 degree, then you must subtract it with 360. So 270 minus 360 you will get minus or plus 90 degree. 450 minus 360 you will get plus or minus 90 degree. Okay, now let us see what is the centroid. So our angles of asymptotes we have got as plus or minus or plus 90 degree. So centroid is sum of poles minus sum of zeros. 1 second. Okay, I will expand the screen. Okay, centroid is sum of poles minus sum of zeros. What are our poles? 0, minus 1, minus 5. And what are our zeros? Minus 1.5. So minus of minus 1.5. N is 3, M is 1. So you will get minus 4.5 by 2. The centroid is 2.25. Just note it down. Just note it down. So centroid is minus 2.25 and angles are plus or minus 90. So now let us go to our graph. Let us go to our graph. So in the graph, centroid is minus 2.25, that is this point, and angle of asymptotes at the centroid is plus or minus 90 degree. These are the angles of asymptotes. Just mention the angles of asymptotes. So draw the asymptotes and locate the centroid point on the graph. Okay then. Now, step number 4, to find the breakaway and break-in points. So for that, let us determine the closed loop transfer function. So g of s by 1 plus g of s. So we have g of s by 1 plus g of s. We are not writing h of s. Why? Because it is a unity feedback system. So even if you won't write the h of s, it doesn't matter. So that's why in this formula I have not written h of s, but h of s will be there. But since it is a unity feedback system, h of s is 1, so we are not writing it, we just simplify it. So you will get an expression, that is k into s plus 1.5 by s into s plus 1 into s plus 5 plus k into s plus 1.5. This is what you will get in the denominator. Okay, take the denominator, equate it to 0. That is our characteristic equation. Okay, that is the characteristic equation for the closed loop system. Okay, that is the characteristic equation for the closed loop system. And just rearrange the terms to get an expression for k. So what is k? What is k? 1 second. Okay then. So k is equal to minus s into s plus 1 into s plus 5 by s plus 1.5. s plus 1.5. So you just take minus common and you just solve this numerator term. You will get minus of s cube plus 6s square plus 5s whole divided by s plus 1.5. This is our k expression. Now differentiate k with respect to s. Okay, differentiate k with respect to s and equate it to 0. Differentiate k with respect to s and equate it to 0. So if you differentiate k with respect to s and equate it to 0, this is what you will get. And just you further simplify it after equating it to 0, further simplify it, you can determine the roots here. For this equation, you can determine the roots. You will get s equal to minus 0.6, s equal to minus 2.3 plus or minus j 0.86. Okay, plus or minus j 0.86 you will get. So these are the s values. Now substitute these s values in the k expression that is here, which is here. This is the k expression, k equal to something, some expression you have got. You just substitute s value. If k is real and positive, then definitely you will get the breakaway or break-in point. So you have got s value as minus 0.6 and s another one is complex term. So just substitute. So I am not giving enough time to write. If you are unable to write it down, you can later go through the video to just note it, to note down these terms. Okay. So now let us check for k. So what is, let us check whether k is real and positive or not. So for s is equal to minus 0.6, substitute in the k expression. If you substitute that in the k expression, it is you have got, you will get 1.17. 1.17 means it is a real and positive value. So if there is, it is a real and positive, definitely there must be an breakaway or break-in point. So breakaway, I have written here, there is a breakaway point. Why? Because in our graph you can see there is a 0, there is a pole, there are two poles, okay, which are meeting here. Okay, two poles, there is a root locus between two poles. So definitely wherever the breakaway point comes into on the real axis, from there the root locus has to break away and to go towards the to meet the 0. Okay, to meet the 0 it has to break away at that point. That's why I have mentioned here breakaway point. Okay. So substitute s equal to minus 2.3 plus or minus j 0.86. If you solve it, I have not shown here, you do it. It's just a mathematical simplification which you can easily do. So you just solve it, you will get k is not positive and real. So this s value, this complex s value is not our breakaway point. So what is our breakaway point now? Breakaway point is minus 0.6. Why? Because k is real and positive for that s value. Okay. So for this s value, k is real and positive. Therefore this is our breakaway point. This is our breakaway point. Now let us locate that 0.6 on the graph. Okay, locate that on the graph, 0.6 on the graph. You people draw the graph along with me so that it will be easy for you. So I hope you have located this breakaway point on your graph. Now let us go to the next step. Step number 5. To find the angles of departure. So if you observe here in this S plane, on this S plane, there are no complex conjugate roots. Okay, there are no complex conjugate roots. So if there are no complex conjugate roots, then there is no need to determine the angle of departure. So here you can see I have written no complex poles or zeros, so no need to find the angle of departure or arrival. Okay, so angle of departure is from the poles if the root locus leaves the poles. Arrival is root locus will meet the 0. If root locus is meeting the 0, that is known as angle of arrival. Okay, so we don't have complex zeros here, so in any other problem, if there are complex zeros, then you will understand what is meant by angle of arrival. So now step number 5 is not required. Why? Because there are no complex poles. Now let us go to step number 6 to find the crossing point on the imaginary axis. Okay, let us see whether there will be any crossing point on the imaginary axis or not. Now consider the characteristic equation which we have already determined earlier. Consider the characteristic equation and just substitute s equal to j omega in that characteristic equation. Okay, expand it and substitute s equal to j omega and simplify it. You will get j terms, imaginary terms and real terms. So these two are the real terms, this one and this one. These three are the imaginary terms. Now equate the real terms to 0 and equate the imaginary terms to 0. So I have equated the imaginary part to 0. So I have got omega square equal to 5 plus k, and equating real part to 0, I have got this minus 6 omega square plus 1.5 k equal to 0, whereas omega square is what? 5 plus k. So k value I have got minus 6.67. Okay, so k value is minus 6.67. that's what I have got. Okay, so what we can see here is k is negative. Okay, therefore there will not be any crossing point on the imaginary axis. Okay, there will not be any crossing point on the imaginary axis because k is negative. Therefore simply what you do is go to your root locus. Okay, go to your root locus. Of course there is a pole here, there is a 0 here, definitely root locus will start from P3 and end at this 0. Next there is a pole P1 from where root locus will start, from P2 root locus will start, and there is a breakaway point. So maybe from P1, from this breakaway point, root locus will travel from P1 and it will follow the path of asymptote. No need to worry about imaginary axis. Why? Because k value we have got negative. Another root locus will start from P2, it follow the path of the another asymptote. Okay, so this is the root locus for this given problem. Okay, so I have not put the arrow marks. So this is it. This is the root locus path from P3 to Z1. Root locus, one root locus. Another root locus is from P2. It will travel from P2 to breakaway point. After that it may travel upward or downward, any path it can choose, and it will follow the path of asymptote. It will start running parallel to the asymptote. Similarly P1, root locus will start from P1, it will reach the breakaway point and it may travel upward or downwards. One root locus will go upward, other root locus will go downwards. Draw it. So I'll start the another problem. Okay, so next problem. So sketch the root locus of the system. Okay, sketch the root locus of the system whose open loop transfer function is given. G of s is equal to k by s into s plus 2 into s plus 4. If any issue is there, if you are unable to follow, just mention in the chat box. Mention in the chat box. So okay, then sketch the root locus of the system. Sketch the root locus of the system whose open loop transfer function g of s is given by k by s into s plus 2 into s plus 4. K by s plus s into s plus 2 into s plus 4. Find the value of k. Here we have to determine the k value. So the damping ratio of the closed loop system is given. Damping ratio zeta. Okay. So zeta value is given, that is 0.5. 0.5 damping ratio is given. Open loop transfer function is given. You have to determine the k value as well as you have to plot the root locus. You have to plot the root locus. So let us start with step 1. To locate the poles and zeros. Okay, to locate the poles and zeros. So open loop transfer function. So I have taken from the open loop transfer I have taken the denominator and equated it to zeros. So to determine the poles, so s equal to 0, s equal to minus 2, s equal to minus 4. Directly you will get, no need to simplify or solve it or anything else. So you will get 0, minus 2, minus 4. So P1, P2, P3, that is 0, minus 2, minus 4. These are the poles. So in the numerator you can see there are no zeros. So definitely the root locus will meet the zeros at infinity. So locate the poles on the x-axis. They are real poles, therefore locate them on the x-axis, on the real axis. Consider 2 centimeter equal to 1 unit. Scale as 2 centimeter equal to 1 unit. So P1 is at the origin, P2 is at minus 2, P3 is at minus 4. Okay, P1, P2, P3. P1, P2, P3. So locate them on the real axis. So now let us go to step number 2. Step number 2. Step 2 is to find the root locus on the real axis. In order to find the root locus on the real axis, so you can see there are 3 roots on the real axis, all 3 are poles. So all 3 are poles. So consider a test point on the left side. Consider a test point on the left side of the real axis. Okay, and look towards the right. Sum of poles and zeros on right side is odd number, that is only one pole is there. So therefore there will be a root locus between P1 and P2. So there will be a root locus from P1 to P2. Now consider a test point on the left side of P2. Look towards the right. Sum of poles and zeros is even number, that is only 2 poles are there, which is an even number, therefore there will not be any root locus between P2 and P3. Now consider a test point on the left side of this P3. Look towards the right side. Sum of poles and zeros is an odd number, which is 3. Therefore there will be a root locus from P3 to nothing else is there. Therefore from P3 to infinity there will be a root locus. So there is a root locus from P1 to P2. There is a root locus from P3 to infinity. Okay, so definitely this P3 must meet the 0 at some infinite point. This is it. So root locus on the real axis. So this is the root locus on the real axis. So we can see here P1 and P2, there is a root locus between P1 and P2. So there must be a breakaway point here somewhere between P1 and P2, from where the root locus will break, and one root locus will meet the 0 at infinity, and another root locus will meet the 0 at infinity. Already P3 root locus has started from P3, it will meet the 0 at infinity on this real axis. Just note it down. If you are able to solve on your own, you just solve it, and you can tell me the breakaway points and all asymptotes. You can tell me centroid. You can mention it on in the chat box. If you are able to follow, you solve it and you tell me. I will conclude this class by 7:30. So now let us go to step number 3. So in step number 3, to find the angles of asymptotes and centroid. So angles of asymptotes formula we already know, that is 180 into 2q plus 1 by n minus m. So what is n? Number of poles are 3, number of zeros are 0, m equal to 0, n equal to 3, and m is equal to 0. Therefore q will vary from 0, 1, 2, 3. Q will vary from n minus 1 is 3 minus 0 is 3. So q will vary from 0, 1, 2, 3. So for these q values we have to determine the angles of asymptotes. So you can solve it, and you can mention the angles of asymptotes in the chat box if you are solving, if you are drawing the graph.